All right, so in this video, we want to sketch out these reciprocal functions and then find the domain and range of the functions. So let's get started with the first example over here. Now, a regular reciprocal function with no transformations generally has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals to 0. And the function is in these two quadrants to begin with. So that's how an original function looks like. A little tiny diagram here. So it looks something like this. You have x equals to 0 and y equals to 0 as your vertical and horizontal asymptote. Now, transformations will stop moving the asymptotes around. So the denominator, anything added or subtracted, moves it left or right. And the number out here moves it up or down. And then there could potentially be reflections. So this one over here is going to move the asymptote 2 units to the left. So it's now going to be at x equals -2. And my vertical asymptote is going to move 3 units down. Sorry, my horizontal asymptote. That's going to be y equals to -3. And then there are no reflections in this one, so I'm still in my two original quadrants. So that one and that one right there. My domain for this function is just x is an element of all real numbers such that x cannot equal to -2. My vertical asymptote and my range is pretty similar. It's just y cannot equal to -3, which is just my horizontal asymptote. That's pretty much how you do these questions. So let's take a look at the rest of the examples. They'll start to get a bit more difficult and quite a bit of variation. So take a look at all the examples to fully understand this. For this second question, nothing is added or subtracted to x in the bottom. So my vertical asymptote stays at x equals 0. My horizontal asymptote is now moved to +2. And I would normally draw it in these two quadrants here, but now I have a negative in front of the numerator. That's a reflection in the x-axis. So if I reflect this in the x-axis, it's going to come down here. And I reflect this one in the x-axis, it will come up over here. So basically the opposite two quadrants from the original. Now, if you also reflect in the y-axis, it would look similar to this because for a reciprocal function, if I reflect this in the x-axis, this comes down and this comes up. If I reflect in the y-axis, this goes to the left, this goes to the right. So the reflections look identical. So a reflection in the x-axis is basically similar to a reflection in the y-axis. My domain is x is an element of all real numbers such that x cannot equal to 0. My range is y is an element of all real numbers such that it cannot equal to +2. Take a look at this third example over here. This one's actually a bit of a trick question because you have a k value and a d value. So you have to simplify it by factoring out the k value. And then you can do the sketch. If I sketch this, I have my horizontal asymptote is now 5/2. It's not 5, which you might have thought from the original question, vertical asymptote. And my horizontal asymptote, there's no number out here, which means it just stays at 0. Again, there are no reflections in this one, so I'm in the original two quadrants. My domain is just x cannot equal to 5/2, and my range is just y cannot equal to 0. Okay, 3 more questions over here. This one, again, I have to factor out my denominator because my denominator has a k value and a d value. So before I even try to sketch it, I'm going to factor out this -3, and this becomes x +2. +2 over here. I can now do my sketch. Vertical asymptote is at x equals -2. Remember, we always flip x, it's the opposite. Horizontal asymptote is y equals to +2. So this one has a negative in the bottom now, which is a reflection in the y-axis. So these are the two original quadrants. Reflection in the y-axis will just be in the opposite too, and the graph is going to look something like that. Domain is all real numbers such that it does not equal to -2. And range is all real numbers such that it does not equal to +2. Let's go to the fifth one here. Again, we got to simplify the bottom there. So -3 over -2 x plus 5 over 2 minus 1. Now, technically speaking, you could cancel these two negatives. It's not wrong, but we're not going to cancel it out because typically they don't want you to do that in these types of questions. So mathematically speaking, that is a possibility. A vertical asymptote is at -5 over 2 for x. And my horizontal asymptote is at -1 for y. Now this one has both a reflection in the x and the y-axis. So when I reflect it in both axes, it's going to reflect to the other two quadrants, and then it's going to reflect back and look like the original. That's why I said you can cancel those out, because technically it's just like a positive equation. The double reflection brings it back to the positive quadrants. We're just going to be in the original two quadrants and look something like that. Domain is just x cannot equal to -5 over 2, and range is y cannot equal to -1. Last question here. This is actually a really simple one. It's almost like a trick question because people don't realize how easy it is. That's why I want to include it at the end. There's no movements to our asymptotes, so just set x equals to 0 and y equals to 0. There's no reflections either. It's literally very similar to the original. There's a bit of a horizontal compression by a factor of 1 over 3, but you don't have to worry about that in a sketch. Domain is just x does not equal to 0, and range is just y is not equal to 0.